For number 30, it's non-calculator for the whole problem. So all my answers, I'm going to leave them in the exact form. I would need the calculator to find the 3 decimal places. So to start A, I need the bases to be the same so I can set my exponents equal. So I'm going to change 4 to be 2 squared. So now I can say 2x equals 5. So x is 5 over 2. For B, I'm going to first divide both sides by 2. $250 divided by 2 is 125. And again, I'm going to make my bases the same. 125 is 5 to the third. So from here, I can set x over 4 equal to 3. Because that's my 2 exponents. And now I can multiply both sides by 4, or you can cross multiply. It's a personal preference to solve for x, and we get x equals 12. For C, there's no way to make 10 and 40 the same base, so I'm going to change this to log form, and that's my exact answer. Same thing for for D with the 9. We can't make E or 9 the same base, so we can change this to log form, and ln of 9 is our answer. Now, 625, that is a power of 5, and that is 5 to the 5th. Nope, it's not. It's 5 to the 4th. So that means 2x has to equal 4, so x is 2. To solve f, I'm going to change it to exponential form, so e to the third. G, I'm also going to change to exponential form. 2 to the x equals 8. Well, I can rewrite 8 as 2 to the third, so x is 3. Another way we could have done this is change the 8 here as 2 to the third. Because these bases are the same, we're left with just 3 equals x. To start h, I have to divide both sides by 3, and then I can change it to exponential form. And 2 to the 5th, you can leave it as 2 to the 5th, or you can write that as 32 equals x. For I, x squared equals 64. And I'm going to square root both sides, and we get 8. It's not going to be negative 8 because you can't have a negative base for a log. For j, I'm going to change it to exponential form. 4 squared, subtract the 9 from both sides, and 16 minus 9 is 7. So for k, first I have to move the 5 over. So then we can't make those the same base, so I'm going to change it to log form. And log of 21 is a number by itself. So when I add 3 over, that gives me log of 21 plus 3. I'm going to write it in the front so that way I don't accidentally add 21 and 3. You cannot do that. So all of that's still going to equal 2x. So I'm going to divide both sides by 2. And this is my answer. For L, first I'm going to divide both sides by 20. And, oops, I forgot my exponent. Let's move this down some. have 1/2 to the x over 3, and now 5 over 20 reduces to 1/4. I can rewrite this as 2 to the negative 1, and I can rewrite 1/4 as 2 to the negative 2. So now this exponent is negative x over 3 equals negative 2, and let's solve for x. Negative x equals negative 6, so x is 6. And the last two parts for m and n, I can make both 4 and 8 a base of 2. And when we have an exponent to an exponent, that means multiply. So we have 2x minus 6 equals 6x plus 3. We'll subtract the 2x to this side and the 3 to the other side, and we get negative 9 is 4x. I'm going to divide by 4, so negative 9/4 is our answer. And for n, first we have to add 17. So 17 plus 8. Remember, you can't use your calculator, so you can always do some scrap work on the side. And divide by 5. And now we can change it to exponential form. There's a base e here, so bring that down to the 5th. And now to get the x by itself, we're going to subtract the 4 to the other side, and our exact answer is e to the 5th minus 4.